Hello, I'm Nick DiFiore, Director of Automotive at Xilinx. I'm here to introduce the automotive grade Zynq-7000 all-programmable SoC, a product ideally suited to one of the fastest growing automotive applications, driver assistance, also known as DA. DA can include visibility features like 360-degree surround view and collision avoidance features such as blind spot detection, pedestrian detection, or lane departure warning. Demand for advanced DA features are posing both technical and business challenges. Designers are faced with balancing system performance, power, and cost, while achieving a level of integration and associated design productivity consistent with limited development resources. Business managers are concerned with IP ownership and product differentiation, platform lifecycle costs, and market timing, all critical to profitability. In order to understand why Zynq is the total driver assistance solution, let's first take a closer look at the functional requirements of a DA system and a traditional implementation. Most DA systems, regardless of features, follow a similar functional architecture. The most common DA sensors are camera and radar. In the case of cameras, data processing at the pixel level is required in the sensing domain to enhance image quality or extract object information. Features like vehicle rear view or surround view require video processing with graphic overlays to provide useful images displayed directly to the driver. Collision avoidance features use additional sensor data processing that ultimately allows for characterization of the environment around the vehicle. This could involve identification and tracking of lane markers, signs, other vehicles, or pedestrians. Decision-making must ultimately be performed to assess threats, warn the driver, or in some cases take temporary partial control of the vehicle to avoid an accident. An optimal solution to these complex DA functions usually requires some combination of customized parallel hardware to process high bandwidth sensor data and software running serially on a processor to characterize the environment and make appropriate decisions regarding driver warnings or vehicle control. Looking at a typical DA system implementation, we see three different devices are used to perform sensing, environment characterization, and decision making. Image capture and pixel processing is performed in hardware by an FPGA or ASIC. Serial element or object processing is performed in software on a DSP processor. And finally, a traditional microprocessor handles frame-level processing and vehicle communication. It's noteworthy that many features must be implemented across all three devices. Now, let's take a look at the Zynq-7000 all-programmable SoC. Zynq includes a complete ARM Cortex-A9 MP-core processor system in a dual-core configuration. This is tightly coupled with RTX 7 series programmable logic on a single monolithic device. A family of devices with different logic densities, all with the same ARM processing system, allow for the optimum level of hardware resources and scalability for spanning low to high-end DA systems. Looking at a Zynq-7000 based DA implementation, a homogeneous software-centric architecture is now possible, where any number of features can be implemented with optimal hardware and software partitioning. The high bandwidth AXI interconnect between processor and logic supports highly granular partitioning through the use of any number of customized hardware accelerators. Traditional DSP processing can be performed either in logic, leveraging available DSP slices, or in software, aided by the Cortex-A9 Neon vector processor. This highly integrated approach reduces bill of material cost, boosts overall system performance, and reduces power over traditional multi-chip solutions, which are disadvantaged by power-hungry, bandwidth-limited chip-to-chip interfaces. Tightly integrated development tools And available Alliance partner software, IP, and reference designs also enable a level of design productivity not achievable with traditional multi-chip approaches. While Zynq offers a superior overall technical solution, that's still not the whole story. On the business side, Zynq puts OEM suppliers in full control, with the ability to leverage third-party software and IP while tailoring their products with a level of proprietary content that matches their particular competitive needs. The high NRE associated with ASIC and the Me Too problem of ASSP are both avoided. Finally, the inherent flexibility and productivity gained from highly integrated, all-programmable silicon, tools, and a ready ecosystem allows Zynq adopters to navigate the time-to-market challenges associated with the rapidly advancing DA market. And as the total automotive driver assistance solution, Zynq-7000 is, of course, available as part of Xilinx's fully automotive qualified extended temperature range XA product line. For more information on Zynq, or to see the entire portfolio of Zynq programmable platforms for automotive, please visit us online at Xilinx.com. And don't forget to like us on Facebook or follow us on Twitter. Thank you for watching.